All right, let's do a few problems together from section 3.6. The assignment was 5 to 13 odd, and 19 through 33 odd. And then with the last ones, they're optional. All right, so here's the first one, number 3. And I'll skip through and just do a few of these to help you out. This one here would be f prime of x is equal to, we got to do the chain rule, right? Because we got an inside function there. Derivative of the outside, and then there's an inside function. Derivative of the outside would be cosine times the derivative of the inside, which would be, we learned this, right? Derivative of natural log is 1 over x. So it's 1 over x. So the answer is cosine natural log of x over x. That's the answer to number 3. I'm looking at Bob Stewie right now to make sure that there's not anything weird going on, because sometimes they simplify things in a strange way that maybe I'm not catching because I'm doing these fairly quickly. So I'm opening up to the Bob Stewie page to make sure that things kind of match up, so what you're seeing is what I'm seeing. And that's exactly the way they leave number 3, which there really isn't anything to do. I just wanted to make sure. Number 9, derivative of the first times the second, derivative of the second times the first. Now, when you take the derivative of the second, you're gonna say derivative of the inside, right? So that's gonna be something you have to keep track of. So f prime of x is equal to derivative of the first times the second plus derivative of the second. Okay, that's the 1 over x thing. So you take it, throw it on the bottom. Derivative of the inside, sine x. The 5's cancel out, so we get cosine x natural log of 5x plus sine x over x. This is number 9, and that's the way they left that one. All right. 15. That's kind of weird looking. 19. Oh, 19 I think simplifies down quite a bit. Let's look at 19. So the derivative of natural log, dy dx, is 1 over e to the negative x plus x e to the negative x. All right, so whatever's inside here, you throw it on the bottom. Whatever's inside, you throw it on the bottom. All right, now we got to take the derivative of the inside. The derivative of the inside would be e to the negative x, but there's an inside function. There's a negative x there, so it's times negative 1, plus, now I have to do the product rule. Derivative of the first is 1, so it's e to the negative x, plus derivative of the second, I just did, e to the negative x times negative 1 times x. All right, so so derivative of this would be e to the negative x, derivative of the inside is negative 1. I got that. Derivative of the first is 1, so it's by itself. The derivative of this is the same as this one, right? Copied it down, times the first. Okay, so this should be good. Now, these cancel out, right? So this would be negative e to the negative x and e to the negative x. So these go away. So that's left over with a negative. So it's negative x e to the negative x over e to the negative x plus x e to the negative x. And we notice that all 3 terms have an e to the negative x in them. So we're going to divide this term, and this term by e to the negative x. And that would do it. So I get negative x over, divide that in there by e to, so I'm dividing all the parts, right, by e to the negative x, divide by e to the negative x. So then that would be 1, and then plus x on the bottom. So that really simplified a lot. The e to the x's all went away. First and second derivatives. So we're going to find the first and second derivative of number 23. So dy dx is equal to product rule and chain rule, derivative of the first times the second, plus derivative of the second. Throw it on the bottom. Derivative of the inside times the first. Okay, so I get 2x natural log 2x. The x's and the 2's cancel, plus x, I believe, right? That sounds right. This is number 23, and that would be the first derivative, x plus 2x natural log 2x. Okay, that's what Robert Stewie has, making sure I'm in the right track because I don't want to waste your time here. Now we're going to do the second derivative. So this is dy dx. So now I'm going to do the second derivative, d squared y over dx squared is equal to product rule. Wait a second, isn't that the same thing again? Oh, it's slightly different. Derivative of the first is 2, natural log of 2x, plus derivative of the second. Throw it on the bottom, times 2 times the first. Derivative of x, 1. The 2x's cancel out. Oh, and then you got 2 plus 1 is 3. So it's 2 natural log 2x plus 3. And that should be the second derivative. First derivative. Let me double check with Stewie. Stewie. This is number 23. 3 plus this. Yes, that's it. Okay, number 31 is the quotient rule. And what do? We take the derivative, and then you got to plug 1 in. So we're finding the instantaneous rate of change at 1. So we haven't done the quotient rule for a while, so that's why I picked this one out to go over. So f prime of x is equal to bottom squared. Bottom. Derivative of the top. That's right. 1 over x. Minus derivative of the bottom times the top. That should be it. Bottom squared, bottom times the derivative of the top, derivative of the bottom times the top. Good. Cancels out an x. Minus 2x natural log of x over x to the 4th power. Now, we could actually divide out an x on each of those because this term has an x, that term has an x, that term has an x. So 1 minus 2 natural log of x over x to the 3rd. That would be a better answer because I divided an x out of each of those. Natural log, so now I'm putting in 1, f prime of 1, means I'm putting 1 in for x. Well, the natural log of 1, we remember, is 0, so the answer would be 1 over 1 cubed, so it should be 1. Number 31, the answer is 1. All that work for 1. Okay, so I think that's kind of a pretty good, write the equation of the tangent line, okay? So on 33, we're writing the equation of the tangent line. So that means you got to take the derivative in this. Well, first thing you're doing is you're making a chart. X, y, dy, dx. 3, 0, slope. So you got to take the derivative of this, which would be dy dx is equal to 1 over x squared minus 3x plus 1 times the derivative of the inside, 2x minus 3. Now you got to put in 3. So that would be what? 6 minus 3 would be 3 on the top, 9, 1 on the bottom, right? Because it would be 9 minus 9 and then 1. So I put 3 in there. So the slope is 3. So it goes through 3, 0 with a slope of 3. So y equals mx plus b would be the equation of a line. 0 is y, 3, 3, b. So b has to be negative 9. So y is equal to 3x minus 9. That should do it, right? Yeah, 3 times 3 is 9, minus 9 makes 0. So there's the equation of the tangent line. So at the point 3, 0, that's the equation, the tangent line. You could type this into your calculator, type that into your calculator, and you would see that. All right, this is now a 10-minute video. Woohoo!